Hello and welcome everyone to today's webinar on understanding cybersecurity tools and processes in information technology, IT, and operational technology OT for DOTs. This is part 2 of our cybersecurity webinar series, where in part 1 we had a webinar to understand the what, why, and how of cybersecurity for IT and OT. Part 3 of our cybersecurity webinar series will focus on national cooperative efforts for cybersecurity in transportation and is scheduled to occur on March 22nd. So we encourage all of you to register for that webinar also. If you don't know already, the National Operations Center of Excellence, NOCO, is designed to offer resources and support the TISMO transportation systems management and operations community. Feel free to browse the entire collection of NOCO resources in our Knowledge Center and subscribe on our website for our newsletter and major TISMO announcements. These links are shared with you in the useful links box on the right side of the screen. For this webinar and every other webinar, a recorded version of the webinar, along with the presentation slides, will be available within 24 to 48 hours in the on-demand learning section of our website. We will have a question and answer session both during and at the end of the webinar. So if you have any questions, we encourage all of you to enter them in the question pane at any time. The questions will be read out loud one at a time, and our presenter will answer each question. With that, I'll hand it over to Rick to start us off with the webinar. Rick?
Great, thank you very much. Hello everyone, and thank you for attending today. My name is Rick Teen. I'm Vice President of Government and Critical Infrastructure here at Mission Secure. We are a OT cybersecurity company. Operational Technology Cybersecurity is our specialty and focus. I also have Dan Park, our CTO, in the room here with me too, and he may jump in with either comments or assist with Q&A if we want to dive particularly deeper. I do plan to break every few slides for Q&A, so don't feel like you have to leave your questions all the way till the end. I'll just ask for questions about every 3 or 4 slides. So I'm going to start walking through the presentation here, and I'll try to do this as logically as possible, but we may jump around a little bit. First of all, it's important to understand sort of what the difference between OT and IT is, and I'm sure many of you on the call have a good grasp of this, but I do find when we're out there talking with folks in the traffic world or some of the other areas that we deal in, defense and other critical infrastructure buildings and industries like petrochem, things like that, we do still see some confusion on sort of where the line between IT and OT is. So this first slide is designed to show you that difference. It's something called the Purdue model that talks about the different levels. And up on level 4 is the traditional IT we all deal with every day, we're using right now. This is your laptops and servers and cloud communication and all that. And you certainly need all of that to be secure. And I trust that really best practices in almost every field, government and private industry, particularly, government agencies are getting better and better about securing their IT, their informational technology. And there are tons and tons of vendors out there, and most everybody's familiar with this to some degree or another. So that's not really what we're going to focus on today. Today we're going to focus on the operational technology, because that's where a huge vulnerability lies that is mostly unprotected at this point. Luckily awareness is growing, but actual protections are still lagging behind. And that's as you get down further in the Purdue model and move down through level 3, level 2, level 1, and level 0, and in each level you're getting closer to the field, to the actual equipment in the field. And at level 0, we're not only in the cabinet, we're actually out to the lights and signals and toll gates, drawbridges, anything like that you have out in the field. This is how IT signals translate from being, IP into, actual, changes in voltage, things like that, that actually change settings on operational equipment. And the gap we see is really down in that level 2, level 1, level 0 area where your whole network can be at risk, both to be damaged, to be held hostage, or maybe even be misused. And that's bad enough as is, with someone changing signals or causing other havoc on your traffic system, especially on its own, or even more so in addition to some other attack perhaps, which is a real threat to be concerned about, is someone sort of using the traffic system to compound some sort of other intrusion, either network-wise or physically, with some sort of dirty bomb or other type of attack. You just think about the ways that could be used to exponentially make the situation worse. But then in the future state, which is coming, seems to be maybe next Tuesday, of connected vehicles, things are moving so quickly in connected and autonomous vehicles, that is creating a risk that not only provides a much greater threat situation for you and your networks, but also a much greater desirability for folks to come in and attack you. The concept has been of security through obscurity mostly in the traffic world. Gee, why would anyone want to attack us? Well, we're finding more and more that we're talking to people who have been attacked at one level or another, and so far most of them haven't been too damaging, but they've certainly been problematic. I find in talking to agencies all around the country that many of them will tell me, we've been attacked, but we're not telling anybody. And unfortunately, that's kind of unfortunate for the rest of you, because you're not really sharing information on that and learning from each other. But hopefully that'll start to flow a little better. But it's understandable. Nobody really wants to admit these attacks because it exposes a vulnerability, and until you can fix it, that's a real problem. So the threats that we'll be talking about here, I'm going to jump into those in just a second, but let me just, I don't know if there will be any, but let me just real quickly ask, are there any questions right now on just the overall concept of OT versus IT? Okay, we can always come back to that, but not seeing any at this point, I'll continue to move on. What are the threats to your operational technology, or really to your entire network, because of your operational technology gaps? They're growing every day. We see these attacks coming wave after wave. If there's a black energy 1, 2, and 3, there's probably going to be a 4 and a 5, right? So we see them multiplying, and networks are being probed both at the IT level and the OT level. And the thing about these OT attacks is, they can come in at any level. Some people are familiar with the Stuxnet type attack that comes in at the top, at the IT layer, and burrows down into your equipment and then sits there and sleeps until it's time to, till 0 day occurs and the attack goes off. There's actually a good documentary called 0 Day about the Stuxnet attacks. And that's one way of using OT to attack a system. For anyone who's not familiar with the bare bones of that story, basically someone, some government entity, perhaps us, perhaps others, decided to attack the Iranian nuclear program and cause damage to it. And it was extremely successful for a period of time, and was able to get into the operational technology of that system, even though they thought they were air-gapped, and basically cause equipment to operate abnormally and basically destroy itself, and created a lot of havoc within that organization. Those same tools, those same processes can be turned, unfortunately, against systems, everyday systems like traffic systems. That's a top-down attack. Other approaches, you can come in through the operational technology and actually get in and damage the equipment itself, or you misuse the equipment and cause signals to not operate the way they're supposed to, or other things like that. But you can also swim upstream and then take over the entire OT network. In one assessment, we had someone who remotely, one of our people is probing a network, remotely was able to use a wireless signal out to a simple, ordinary traffic cabinet and they were able to get into the middle of that signal and take over the cabinet. And once they had the cabinet, they were able to swim upstream and had control of the entire statewide traffic system, coming in through one single cabinet through one single wireless signal. So that's how dangerous this is to have your equipment exposed out there. We use a little, traffic light with an explosion next to it, and we used to just, reference that as being impact. But our folks did discover that a certain way of cycling the batteries in a cabinet might actually be able to make a cabinet explode. And we actually talked with a company that does those sorts of power supplies, and we told them what we were talking about doing, and they said, yeah, that would explode. So maybe the explosion logo there, symbol, is really not too much of an exaggeration. So that's sort of the approach that a hacker could take to come into your network through all these different approaches and really take it over or shut it down or do whatever they want with it once they're in. Moving on to the next slide, these vulnerabilities exist at multiple levels within your system, and there are different vulnerabilities based on the level. What is a hacker going to do? Well, at level 2, this is sort of the human-machine interface. This is where your people are overseeing your processes. Well, they can have a loss of view or a false view, so you don't really know what's going on. You don't have control of your equipment anymore. Getting down further, if they get in and take over the equipment like an ATC within a cabinet or other controllers and other types of equipment that you might have, they can actually change how it operates. They can cause damage to the equipment. They can, spoof a normal signal back to the network, so you think everything's fine while bad stuff is really happening out there. And of course, it's another way of kind of getting in and stealing data. And that was, for example, the Target hack is fairly well known, where they came in through the elevator or HVAC system, I can never remember which. And that's how they got into the overall network. They came in through the operational technology, and they ended up stealing all of our, personal data off of if you've ever shopped at Target. So it can be pretty bad. Then getting actually out to the field cabinets, where you can, actually change sensors. You can get in between the sensors and the cabinet itself, and also sending false data, out either back to the system or, and then from there out to actual connected vehicles and things like that. So let me take a quick breath there. Any questions so far on just the overall how you attack an OT system? Okay, not seeing any so far. We're going to start talking specifically more about a traffic system, transportation network now. This diagram, we generally get pretty good feedback. This is a decently accurate diagram of a ITS network going out to a traffic cabinet and out to the equipment in the field. You basically have unsecured connections out to the field. Coming in through the switch, and then within the box itself to the ATC, and out to your equipment. And more recently, adding in the factor of DSRCs, or it could be the cellular approach to talking with connected vehicles. Either one is equally vulnerable. I actually brought that up at a conference just recently with several different experts in the field, and they all agreed that there's different pluses and minuses about the different possible future ways of connecting connected vehicles and communicating to them. But the one thing they all agreed on is they're all equally vulnerable. So that's something that we need to be extremely concerned about as we go forward before those can really go live. And what's needed in the traffic world, or really in any operational technology system, you really need to have a full circle of protection. The first thing you need to do is be able to truly monitor not just your IT, but your OT also. And that's where we find that to the degree that anybody's got pieces in place, if they're doing any monitoring at all, they're really just monitoring at the IT level and not out and having visibility out to their OT. The next is being able to detect either malware or anomalous behavior, breaches, that sort of thing, in real time, and be aware of them, not after the fact, but as they're happening. Being able to inform the operators of the system that something strange is happening on your network and the necessary details of what that is, and then actually being able to correct it, whether by operator intervention or in many cases an automated, either blockage of the attempt, or the informing the operator and giving them options to, click here, here, or here to block the attempted attack. Or in a fail-safe situation, be able to revert to some sort of normal or safe state. Either revert to its prior configuration, which is obviously ideal, but if that's not possible, revert to a safe state. In the case of a traffic cabinet, a flash mode, or whatever it is you want it to do, if all else went wrong. And then one piece that a lot of folks tend to miss is the collect. You really want to collect the data of what just happened so that you understand how you were attacked, what the attempt was, to what it was targeting, and to the greatest degree possible what it was trying to accomplish, so that you can protect against it in the future. We've done some work with the Navy, and one of the things we heard from them regarding these, naval ships and private ships bumping into each other in the Sea of Japan, which is pretty awful, and it does have some earmarks that look like there could be cyber involved. One of the things that we heard from the folks we worked with there was one of the difficulties they're having is they don't really know at any given moment exactly what position. They don't have evidence of what position the rudder was in at any given moment. They know what it was supposed to be doing. They know what the command was, but they don't actually have even monitoring on it to know that it was actually doing what it was told to do. And having that data can be those analytics can be really crucial in planning for, protecting against future attacks. Dan, do you have anything you'd want to add at this point, or I'll just come back around on any questions? Does anybody have any questions so far? I think I may see one here. Yes, so I have a question. Can a hacker breach the central traffic management through a signal cabinet? Sorry if I missed that, didn't notice that question earlier. I think we've already addressed it. Yeah, we've actually had scenarios where we've done that as part of assessments and been able to get in and do that upstream. We can certainly go into more detail with you if you want to contact us on exactly how that's done. We don't tend to broadcast that too widely, obviously, but that's absolutely possible. We know of situations where the entire traffic management system is almost like something out of the movies. You can't go to four-way green because of the conflict manager, and that's the conflict managers are a beautiful thing. It's in their old-fashioned simplicity. One of the funniest things is the idea that it's one of the hardest things to beat because it's so old-fashioned. And then I was at a conference a few months ago, and the next version of the cabinet design, standard cabinet, is going to have a software conflict manager. Our hackers here just got a big smile on their face when they heard that, because that's the simple old diode conflict manager is one of the hardest things to mess with. We can do some really bad things to a signal anyway, with short of going green. But yes, it's a lot like some of the movie stuff. You can actually get in anywhere you get into the network. That ability to swim upstream makes it extremely dangerous. It's not just one cabinet that's at risk. Thanks for the question. Any others? Okay. So moving into what sort of vulnerabilities are we seeing on traffic systems, and this is just a sampling. And there obviously can be a lot more of them. We also don't tend to distribute this document too widely because we don't want the world to know about some of these risks. But first of all, there is no such thing as a true closed system. Referenced the Iranian nuclear program earlier. They were air-gapped, but you talk to hackers, and air-gapped is a headache. But it's not something they feel stops them. They're able to overcome it. traffic systems are nowhere near a closed system or an air gap system or anything. There are many, many ways of getting into both up at the network level or out at the field cabinets, obviously. You know, we all know about number 2 keys and who's seen people, you know, drill or crowbar open a cabinet. I mean, that's one physical way of getting in there, but more and more there are wireless ways of getting into cabinets, much less getting in somewhere further upstream and going down to the cabinet level. And connected vehicles are just going to add a huge number of additional points of vulnerability out there in the field talking to your network. The impact of that, obviously, if you can get into the cabinet, as we just discussed, you can not only mess with that cabinet, but you can go all the way up to the op center and take over the whole system. The next one, no authentication. I mean, basically, what we find in the field is most of the communications out to your field equipment is pretty wide open and easily accessible, and again, that can be pretty easily breached at multiple points in the process. And again, that allows you to kind of go in and go down to individual intersections and create problems there. Or, again, once you're in the network, you can really go anywhere in the network most of the time. This is where we've seen things with power systems and stuff like that too. You can, send bad information into those systems. You've got extra services that we find vulnerabilities with, and of course, more and more as we move into roadside units, the ability to change the spat data that's going to the vehicles. This is a big concern. If you're putting any sort of connected or autonomous vehicles on your roads in the near future, you just really have to be aware. I mean, there's been a fair amount of discussion of securing the vehicle itself, and that's important. You definitely want to secure have the latest security on the DSRCs, on the vehicles, on the RSUs, and all that. That's all important. But if all of that is communicating with a traffic cabinet technology that was designed in 1983, that you're really just leaving yourself wide open. I often liken it to this is like double bolting every door and window in your house, but leaving the garage door open and the door unlocked between the house and the garage. No matter how secure the rest of the place is, if you leave that other entrance open, you're going to be facing problems. More of the vulnerabilities. We find almost no one who's actually doing true OT network monitoring. Plenty of IT network monitoring, but very little OT network monitoring. So you really don't know what's going on out there in the field, out near the edge of your network. There's very little prevention happening in the OT world right now. So if the attack can get in, once it gets in, it can really run wild and do just about anything it wants. And that can either damage your equipment so it has to be replaced, or just put it into a mode where it constantly has to be reset. We have a hack here that we play with that's just it crashes the ATC and the cabinet's operations, and you have to send someone out to reset it, and it resets, and it basically starts a timer, and 15 minutes after it's been reset, it crashes itself again. They'll just keep doing that over and over and over, no matter how many times you send a technician out to that cabinet. That's a nuisance, and could be dangerous. Obviously that's a low-level type of thing, but it just shows some of the things that can be done when you don't have protection in place. The restoration capability, there's no forensics, like I said, not being able to tell what did happen after action, and being able to look at that. And of course, your physical access, you're trying to protect devices that are publicly accessible. They're out there, literally on the side of the road, literally on street corners, and there's only so much you can do to prevent physical access to those also. So, before I move on to what do you do about it, any other questions about the vulnerabilities or anything? I don't see any on the screen. I guess we've pretty much got folks muted, so please insert your questions through the question process here. So, how do we go about starting to protect things? Well, first of all, you have to have an understanding of what your gaps are. And the word assess can be a wide-ranging word, you know. We do everything from very small spot assessments simply to help somebody understand the overall scope of their problem, and that can be very, very inexpensive, sometimes even bundled into a small, you know, a first project, pilot, that sort of thing. It can be a great way to start. And so you learn a little bit about your vulnerabilities and understand, you know, how much risk overall that you have in a general way. But then deeper dive assessments obviously get more complex and more expensive. But, you know, obviously having a greater knowledge of what your gaps and problems are can be huge. So you really need to understand your as-is situation. You need to understand where your vulnerabilities are. And some of those are looking at the technology itself, and some are looking at processes and procedures, and then, you know, comparing those to, you know, standards like, you know, NIST and that sort of thing. Also, the option of having, you know, actual red team attacks, and you know, we've done that in cases too, and it's usually pretty amazing what we find. And also the traffic analysis. Always end up using the word traffic here two different ways, but the IP traffic that's flowing across your network. We have a device called an MSI-IDS that we hook up, and it's always amazing to our customers and even to us when we hook this thing up, how much extraneous stuff is going across your transportation network that, you know, we always have customers say, wow, why are we going to this website? Why is it pinging that? Why is it communicating with that? Stuff just gets into your network and then starts, you know, if one technician from one vendor hooked up to your network and then went back to his, you know, some server on his network 2 years ago, very good chance that something on your network is pinging that server constantly because the communication happened once, so it's repeatedly trying to make that connection. There tends to be a lot of junk on these networks, and you know, ideally you want to clean that stuff up because first of all it's clutter, it's probably slowing things down, but it's also, you know, potential vulnerabilities. And then you need to design a true, you know, cyber protection strategy that includes, as you'll see in the next few slides, human elements, procedural elements, and actual protections. Next slide here. This is a sort of a snapshot of what a quick assessment, you know, first look assessment would be with a customer, and this is a fairly typical type of situation that we find where you have, you know, a few things you're doing well, and usually, you know, and no pointing fingers because really we haven't found anybody in the OT world who's really completely on top of this yet. So usually a lot of vulnerabilities within your operational technology. So this is sort of a scorecard that you would get, you know, early on in the process to understand where you stand and how much of a gap you have to get to at least a reasonable level of security. Any of these things on the slide, they probably look, you know, pretty familiar to a lot of you. Generally, when I'm doing meetings with, you know, with customers and all, they tend to recognize pretty quickly that, you know, a lot of these things are gaps that they would have on their system itself. You know, you've got no patching, and you're not, you know, you're not looking at your disaster recovery and backup plan, and you know, for the OT, maybe for the IT, but don't have things in place for that. So, you know, we kind of give you that, you know, orange, yellow, and red look there. One of the things that definitely needs to be done is some penetration testing on your equipment. We do both, you know, field testing and pen testing in a sandbox environment in your lab, in our labs here. You know, this is a shot of most people recognize probably a design. I don't want it in any way. This is not an indictment of McCain. These cabinets are all designed basically the same, but just down the hall from where I'm sitting here, we've got a McCain cabinet and some other equipment from several other vendors. We use that just for our own in-house testing, but also, you know, we go out to various different customers and, you know, setting up stuff in their labs. We were just at Vegas recently and doing some work there, and other places where we've got stuff in the lab, in the field, and you know, seeing first of all, what the vulnerabilities are, and then, you know, how effective the solutions we add on top of those. It's not all about technology. I've heard people in this field go the full range of, it's only about technology. It's all technology solutions. I've heard, unfortunately, too many people on the other side too about, well, first things first, before we add any technology, we have to solve all our problems with our personnel and our people and our processes. Really, right from the start, it should be a balance of both. You should be looking at improving the situation with your people and your processes and your technology hand in hand right from the beginning. Otherwise, your process is probably going to be too slow. You're going to be a year from now still working on your people and your process, and meanwhile your underlying technology has been wide open. If you can close technology gaps on day one, why would you not do that while also working on your people, your process, that sort of thing? So to my view, they should all go hand in hand and as part of a process, not one after another. But some of these, obviously, the first is just simply awareness. Too many people in the field aren't even really conscious of how much risk there is in their operational technology that undermines their IT network. Most of your people have probably not undergone cybersecurity training. You probably don't have necessarily policies and governance specific to your OT. To the degree that you have any, it's probably IT-based. Recovery plan, pen testing of your equipment, hardening your equipment. Now we're getting into the technology side. Hardening your equipment, making sure your equipment is periodically tested, because just because it was good enough in March doesn't mean it's good enough in September. So periodic testing, continuous monitoring. Ideally, you have either an internal tool on your network or you have some sort of cloud tool, whatever it may be, that's monitoring your equipment from an OT and a cybersecurity point of view. And we don't find many places that have that, but that's something that you really want to have in place. You want to have blocking and ATC monitoring. See, I'm not going to read these to you, but dual format encryption, dual format authentication are really, really big, because that's where you can stop an attack from spreading all through your network. So even if somebody can get into one cabinet, they can't get into all your cabinets. And then back to some human ones again, back to complex passwords. How do you interact with the ATC itself? Don't have your IP addresses or your network diagram written, taped to the inside of the cabinet door. That just creates a shortcut for the person. If someone physically opens your cabinet and you've got basically the roadmap to your network on the cabinet door, that's obviously making life easier for them. Now, implementing an actual platform. So we talked a little bit about your people and your process, but you need to actually protect the equipment. I've tried to, in this presentation, not talk too specifically about Mission Secure and our products, but obviously in talking about a solution, best example I can give is our own, because I know it, and also we do find that there really isn't anybody doing exactly what we do and how we approach this. We hear all the time from folks. So just to give you an example here of what a solution we would recommend in addition to your people and your process, this would involve putting actual software and hardware in place on your network or cloud-based from the software point of view to monitor your situation, to see what your network traffic is with an IDS, actually monitoring the information that's going across your network. And in the case of a traffic cabinet, we have a device we call the MSI-1. That device actually goes in the cabinet. It protects the cabinet itself from both bad communication, malware, spoofed attacks, things like that coming down from upstream. Also helps protect it being hacked directly. And then another thing that it does, which is really key, is if you're able to take over a cabinet and somehow defeat or rip out, our device in a cabinet, you've now isolated that cabinet. You can possibly take that cabinet over, but you can't swim upstream and infect the rest of the network. Because, as you'll see on the next slide, we actually create a secure tunnel between each cabinet and the head end that way. The one device we've left out here, we wouldn't use in a traffic cabinet situation, but you'll see a thing in another later site called the MSI Sentinel. That's something that would go actually out on the actual field equipment. We don't really think it's necessary in a cabinet. It certainly provides some value, but it's kind of overkill. But if you're talking about toll gates and air handlers for tunnels and other operational equipment, drawbridges, things like that, actually the Sentinel would be a good idea also for those endpoints that don't have, main thing is things that don't have a conflict manager on them. So here's what this would look like in your network diagram. You would have the MSI console, in this case, monitoring your overall network and looking for anomalous behavior. And I'm going to give them more detail on the next slide. You'd have the MSI IDS that's just gathering all the data that's flowing across your network so you can better analyze that and understand what's going on. But then the MSI ones out in the field and in a a many-to-one communication back to your operations center, so that if someone were able to get into a cabinet, they couldn't then swim upstream because the equipment up at the head end is only going to trust communication that's been through the MSI-1 that's out in the field. The MSI-1 generally goes either in front of the switch or between the switch and the ATC. And that helps protect the actual cabinet and the communications, everything out to the cabinet to make sure, out to the cabinet and within the cabinet to make sure that it isn't being taken over and misutilized. Let me take a breath here. Any questions on that so far, and I'll go into a little more detail. I'm not seeing any come up on the Q&A. I don't know, Neil, if we can open it up for voice for questions. Would that make it easier on anybody?
So I think we can unmute people, like if somebody requests to talk, we can unmute them, but for now, we can use discussion pod and question pod.
That's fine. That's fine. I just want to make sure we're making it as easy as possible to answer questions. These next two slides are specific to our stuff. I don't want to be pushing one thing too much, but just so you understand the concept of what's out there. What does the console do? You can see here, this can be installed on your network or remotely, and this monitors your overall system and looks for things that looks for malware type behavior, looks for intrusions, and overall it also manages the communication out to all the field devices. The MSI IDS is more of a passive monitoring tool and helps you troubleshoot issues. The MSI-1 is the actual protection out at the cabinet level. And the MSI Sentinel is actually down at the lowest level between, say, the cabinets and the lights. Like I said, we generally don't recommend it in a traffic light situation, but we would recommend it in other parts of of your network. The idea here is that we've come across too many folks who have said, or either have said they plan to, or have actually tried utilizing firewalls, regular traditional IT firewalls, to secure their field equipment. And as a matter of fact, the McCain cabinet that you saw, that came with a firewall on it. And when we asked the guy, we took that cabinet and put it in a room and took a young kid who had just started working for us and basically said, we're going to put you in a room with a piece of equipment. We're not telling you anything about it. Just, see what you can do to it. And he came out in 42 minutes and said, okay, well, I've got full control of it. Does this have something to do with traffic? So he was able to take it over very quickly. The firewall was, just a bump in the road. These IT firewalls are great as IT firewalls. They are not designed to provide the protection you need in a field cabinet. Also, they're way too expensive. You're generally talking, $1,000, $1,500 or more for a firewall like that, and it's not hardened. It's not designed for field use and weather protection, things like that. The stuff we make, we think what you need is things that are purpose built for an OT network, and that's the approach that we take. Is the equipment we build does the things you need in an operational world. A firewall does 4 or 5 things that are helpful and a whole lot of stuff you don't need in an OT environment. Whereas the MSI-1 is designed to do exactly the things you need in that type of environment. So that's, again, I don't want to sound like I'm pushing this stuff. I'll leave the slide up. You can see, but some of the key things are, the authentication, two-factor authentication, creating basically a secure tunnel back to your head end and everything are really key, and it goes far beyond what a firewall would do. Got a question here. Okay, can I talk about cost generally? Well, here, I'll just read the question. Can you talk about cost generally, grant opportunities, and how you might see this trickling down from DOTs to other agencies with managing critical intersections that would be bigger targets? That's a great question, actually, Chris. We actually find this is a common discussion with customers of, well, first of all, what's it going to cost? And we purposely, we know that there are not, unlimited budgets for cybersecurity in this field. You probably need a lot more budget focused on that. In many agencies, it's probably close to zero. But what we found is, we're able to come in and do projects ourselves, and again, that's all I can speak to. But starting, in the $40,000, $50,000 range, and start protecting a network, including doing an initial assessment. The equipment itself for the cabinets is actually very inexpensive. We're talking about around $400 a cabinet to protect cabinets. And now I know that when you're talking about that versus zero, that adds up. So there's two factors I found that have been interesting in talking with people. One is, first of all, just as you said, starting with your critical intersections. So to speak to how we do things, you would have an MSI console, you would have an MSI IDS on your network. Both of those things are going to improve your situation noticeably. You do want to have the MSI-1s in the cabinets to be much more secure. You never use the word completely secure, obviously, in any field, but much more secure than you are now. But we often have customers who say, well, let's start with my 10 or my 20 most critical intersections that concern me the most. Either A, if somebody wanted to get into them and use them to attack the network, that's where they probably would go, or these are the intersections they would want to mess with. It's the Vegas Strip, the downtown intersections, the ones near your football stadium or arenas that people would see as the juiciest targets. So that's a very common approach, is to start small and build up from there. Another trick from a funding point of view that I've seen people start to talk about is trying to just get a standalone line item for cybersecurity, though it's very worthwhile, can be difficult to move through your processes and get on your budget and everything. But I know several agencies who are simply now trying to write cybersecurity standards into all of their other equipment requests. So simply saying, if I'm going to buy cabinets from now on, I want my cabinets to have security on them. When you look at the incremental cost of adding security to a cabinet, it's not really a very large number, right? If you compare it, here's your cybersecurity project compared to not spending anything, that seems like a big number. When you add cybersecurity to your next 400 cabinets you buy, it's going to be a small fraction of the overall cost of those cabinets, or 30 cabinets, or 50 cabinets, or whatever. Hope that was helpful. As far as grants specific to this, we haven't really seen any yet, though I've had some very interesting discussions with US DOT folks who seem to recognize that maybe they need to try to provide some leadership there. But the other possibility is I'm aware of several projects that are connected vehicle projects where, for a tiny sliver of the overall budget, you can secure this. And if you think about it, you really should, because if you're trying to run a connected or autonomous vehicle project, this year, and you're running that on, you probably have all sorts of specs in there about how the DSRCs have to demonstrate their security, and how the RSUs have to demonstrate their security, and how the vehicles have to demonstrate their security. And there's probably nothing in there about how your old-fashioned traffic cabinets and your overall network have to demonstrate its security. And I kind of liken it to those of us old enough to have ever played with one of these. If you secure the soup can and you secure the string, but you don't secure the other soup can, you don't have a secure system. And right now, that's the danger. And what I really, I believe in autonomous and connected vehicles as much as I love to drive myself. I believe in the concept, and it's important that we'll go there. We'll save a lot of lives, and life will be much more efficient. But I'll tell you, if somebody hacks into just one of these pilot programs and takes over vehicles or takes over an intersection, worse yet, and you don't have to hack the vehicle. If you hack the traffic system and just tell all the vehicles approaching an intersection that the light is green and there's no one in the crosswalk when the light is red and there are people in the crosswalk, you're going to set this whole world of connected vehicles behind 10 years or more. And so that's where we see the need to tie this in. And so going back to Chris, your question about grants, having this be part of other grant projects, I think, is a really wise move. And I've already had a few people who we're talking to who were, had a grant for connected or autonomous vehicles and are now rolling cybersecurity into that project. So that at the very least, even if their overall network won't be secure, the part of their network they're using for the CV and AV project will be secure. So that's their biggest fear. Any other questions we can answer? Just, little bit about us at the end, but again, I'm not going to really talk to that. We've been through a lot of testing. We started out in the military primarily, and that's where our, company focus initially was, but we've recognized that there's a huge need here in the traffic world, in the petrochem world, building control systems, things like that. So we're now branching out into these other areas. Agencies that are leading the charge on this. I don't know if I can speak. I don't really have permission from all of them to do that. We're doing some interesting work. I don't think they'll mind us saying. The city of Las Vegas has an autonomous bus project. It's very interesting. Many of you may have read that it was involved in an accident on its first day when it launched, but that was not its fault. That was the human driver hitting the bus, not the other way around. But it's off to a good start, but they've recognized the need to beef up their cybersecurity on that project. I've talked to a number of people in, I'll just be vague and say several cities in Florida. We're trying to do some things in this area, some New York, some of the places you'd expect, but also, there are, cities and towns who kind of recognize this, who just, had somebody who's been exposed to the cybersecurity risks and are trying to do more with it. We've seen some people in the academic world. If you want to talk about people in the field who really understand the issues and concerns, certainly some people you'd want to talk to would be like Ed Falk with Federal Highways out of California, Mike Dinning from Volpe. These are folks who have been working in this area for a little while, and from my discussions with them, the big thing has been they haven't really been aware of solutions. They've been aware of and trying to alert people to the problem, but they weren't really aware of solutions designed for this space. So it's been a matter of trying to sort of, put buckets under the leaking roof rather than go up and, and repair the holes. And now we're able to, they put us in touch with some people to help them, repair some of those holes. The folks at Turner Fairbanks here in Virginia I know we're doing some work, Deborah Curtis and her team, and Ken Leonard, Kate Hartman, they've become aware of this stuff. So those are some leaders up at the national level who I think are trying to help build awareness there. But states and localities, we're certainly working with some of them, and we've actually found some very willing partners in the industry too, who recognize that their equipment, was not designed with cybersecurity in it, and they're becoming concerned. And for example, we've talked with Trafficware in a few situations. They're very interested in having having cybersecurity added to their systems so that it's more secure and protected. I hope that answers your question. Let me ask out to you folks. I know it's a little hard to have a dialogue here, but feel free to chime in, I guess, through the question portal. But do people feel like you've got a handle on cybersecurity, or are you just really becoming aware of it? I'd be curious for anybody's, not so much a question, but anybody's feedback on what they and their agency are doing and what they've learned. I don't want this to all be from one perspective. Not having any other questions at this point. Let me ask Dan, do you have anything? Dan Park is our CTO. He works directly with some of our customers. Anything you'd want to add to the overall discussion here, or what things people should be most aware of, or taking?
I think really just I think it's reiterating kind of what you touched on, which is that security is not a silver bullet approach, and I think everyone may already understand that, but you can't just rely on one thing. It's going to be a layered solution that you're going to need to do and address at different levels in different areas. And as Rick mentioned, it's not just about technology solutions, but it is definitely and absolutely people and processes and policies and so forth. So it's something that is not done overnight as well. But I think the benefit is that once you're aware of the issues, you can start layering in those solutions over time. And I think one critical piece is to really understand where you are to then set a path forward. So absolutely understanding where are your vulnerable points, where are your key and critical weaknesses, and then trying to address those at the lowest cost possible. So this doesn't have to be a huge money sinking endeavor. It can certainly be something that you can start out small and still at least get some incremental improvements to your overall security.
Yeah, I think that's a great point, Dan. I think the idea of having a better idea of where your risks are is sometimes we sort of don't want to we don't want to look at what might be swept under the rug, but it's better off to get a handle on that early and at least know and understand those vulnerabilities so you can be prepared for them even if you're not ready to fix them yet. I do have another question, and Dan, this might, somebody who's designed a lot of networks. Here's the question. It seems like most of the countermeasures are at the design/detailed design level. What should be done at the conceptual design level?
Conceptual design level. Well, I would say you really want to look at your overall layout and ensure that you have visibility and clarity and plan for growth. I think a lot of things that we've seen so far has been that things have just kind of grown over time, and I understand that you can't predict the future in terms of how all the partners and third parties and other agencies possibly may be interacting or connecting into and integrating into the traffic systems, but certainly not just putting in some kind of dead-end type of architecture, but really accounting for as much as you can and not letting it get out of hand, because I think that's one of the the biggest risks with security is again, not knowing what you have, and as things get patched and bolted on and things like that, you can very quickly lose the security you may have had at the very beginning. And so I think from conceptual origins, you certainly want to look at all the different kind of partners and hooks that may come into the system that you're actually looking at and focusing on.
Yeah, and I think maybe just to add to that, based on things I've heard from folks in the field, one of the things that's tough is that it's not like you're able to sit back and say, hey, what should my traffic network look like next year, 5 years from now? You're tied to, you've got this huge ball and chain of, 20, 40, 50 years or more of transportation infrastructure, tied around your ankle. So you can't shift very easily. A question I get very often is, should we just, the world needs to move to, traffic cabinets being built with security in them. I was just on something last week. Actually, I think it was maybe the last version we had, part one of this webinar. Somebody asked, so do we have to just replace our existing infrastructure? Well, that's an option, but it seems like an incredibly expensive and difficult one. What's much more likely a scenario is to layer security on top of what you have. And I will tell you one thing that I hear all the time is that people who've had professionals come in and talk about how to secure their OT network. One of the frustrations I hear from them a lot is most of what I got told in that assessment was what I wasn't allowed to do anymore, how I had to disconnect this from that, and I had to firewall off this from that, and segment my network and all. Well, the problem is, your network is probably shaped the way it is, right, to do the things you want to do. If our only answer to cybersecurity is now you can't do the things you used to want to do, but you're more secure, well, that's, I guess, a better answer, but it's not really a good answer. So the approach should really be, how can I continue to operate the way I want to operate, but have security layered on top of that? And I think that's a key element. I think I hope this is pertinent to the question, that really what you kind of need to do is look at, living with your as-is situation and building from there, because it's not like you can start from a blank sheet of paper. And I do think this all ties in with, I'm blanking on his name right now, and he'd be very annoyed. But I've seen him speak on this a couple of times, the new president of ITS America, used to be out of Colorado, Mr. Bott. Forgetting his first name. He talks quite a bit how, we can't build out of our growth problem. You're not going to double the number of lanes or triple the number of lanes that you're going to need, right, if we just keep doing things the way we've done them over the next 20 years, 30 years. The only way to do that is to become smarter, and that's, smart highways combined with smart vehicles, and now you can carry 2 to 3 times the traffic in the same number of lanes, right? And, the only way to get there is to get smarter. But the other aspect, and he and I were just discussing last week when I saw him at a conference, is you have to be, that has to be secured. Because if you don't secure it, it'll never be trusted, and you'll never be able to move forward with it. And so you have to not only grow through making things smarter, not necessarily bigger, but you have to make them smarter and at the same time, more secure. And that maybe goes back to the earlier question about budgets. I think cybersecurity just really has to be built into any growth budget, any smart, any budget that's going to either, increase your traffic load somehow by better managing it, or buying, new equipment, refurbishing equipment, that sort of thing. But also going to any sort of smart equipment, you should really have a cyber component built into your request required. I mean, you can really then push the cost onto the bidders. They need to, ultimately that cost will come back to you, but it will be built in. It won't be a separate line item that you have to justify up the chain. It'll be in order to have what the bosses approved and funded, in order to have, what the voters voted on, whatever, in order to give them what they want, there has to be a cybersecurity component built into that. And just by building that into your requirements, you now basically make that budget part of just the overall. Are there any other questions or comments? Like I said, either one is good. We'd love to hear what people are doing, where they feel they're at, if they've made a lot of progress or found something that worked particularly well for them.
Rick, there is a question that was asked before in part one, and I think it is worth maybe talking about briefly here today. So for a DOT that is just getting started, do you have a recommendation of what to focus on initially? And I know you mentioned critical infrastructure, but can you specify that a little bit more?
Well, so you said for an entity that's just getting started, did you say?
For a DOT.
A DOT, sorry. A DOT that's just getting started. Yeah, if you're just starting to look in this world, what I would actually strongly recommend, we've actually built a package for this because we were getting this demand. We do sort of a combination pilot and assessment wrapped up in one. And sometimes you have to be careful because, if you hire somebody to do the assessment, they can't necessarily help you solve the problem, kind of a thing, and this helps maybe avoid that a little bit. The idea is that rather than just get an assessment that tells you where gaps are, you actually get some experience with a way of closing those gaps. And so what we're doing in that case is basically coming in and doing a, not a deep dive assessment, but an initial assessment of the overall network and what some of the biggest gaps and vulnerabilities are, and we always find plenty. I mean, that's sometimes you think, well, would I rather have the deep dive? Yeah, eventually you want the deep dive, but the deep dive is going to be expensive, and it's even the initial one will give you plenty to work on. It'll give you the low-hanging fruit to start working on, and you combine that with all bundled up in one package, the ability to actually have some software and hardware, put it on your network, first in your lab, then in the field, and actually see what the future looks like where you actually have, secured intersections and a secured network. And then that helps you, really see the path forward of how to then, solve your problems. It's a very economical way to go, and it sort of gives you two aspects that you need to understand both simultaneously as part of one project. So that's, we've worked with customers who just want to go straight to, putting in equipment, and that's great. Of course, we love that. We have customers who want to assess and assess and assess and assess. We'll do it for them. We want to help them move towards solving problems, not just identifying them. Especially given how the rate of the hacks are increasing in both severity and number. So our view is let's get some protection in as quickly as possible too. So we found that mixture is really a great way to start.
Thanks, Rick. I don't see any more questions. So do you have anything to close? I just wanted to mention a few sentences.
Yeah, no, thank you everyone for your time. We obviously would be delighted to talk with anybody. I'd love to learn what folks are doing, get feedback. We know that a lot of times, when we first start talking with people, they're really just in information gathering mode. We completely respect that. We've also, done a fair number of these sorts of things where we're trying to, do educational briefings. So we'll do regional meetings or webinars or conferences, things like that. So keep that in mind. I'd be happy to do that. I do. I assume there are no PDHs for this, though. Please let us know by sending a follow-up email. I mean PDFs or? Actually,
I think this is more toward us, like they're asking for for professional development hours.
Oh, I'm sorry.
Yeah, no, this webinar does not provide any PDH hours at this time.
Sorry about that. But anyway, so if there are ever any where you just want to, any opportunities where either within your organization or within a regional group or anything like that, you want to just raise the education level about the world of cybersecurity for traffic, we're happy to do those. It's not just, our business. We also think it's important that people start to grasp how dangerous the situation is right now in some of these fields, and traffic is one of the ones we think is extremely vulnerable to attack. So anything we can do to help elevate the discussion, we're happy to do. And my contact info was on the screen, and there will be actually, I believe, a PDF of this presentation, except we are going to take out those 2 slides that list vulnerabilities. Sorry, but we don't like to leave those floating around there. So those 2 slides in the middle that listed a lot of the vulnerabilities on traffic systems, but the rest of that will be available as a PDF.
Yes, yeah. Thanks, Rick. Other than the slides, the recorded version of the webinar will also be available through our website. I really want to take a moment and thank everyone for attending today's webinar, and I also want to thank Rick. He shared some good information here today with us. And that's pretty much it. On behalf of National Operations Center of Excellence and our presenter here, I want to thank you for joining us today and wish you a great rest of your day. Thank you.
Thank you.